Hi students, my name is K. Narash, working as assistant professor in the Department of Civil Engineering. So today I am explaining about wastewater treatment. It is the part of the environmental engineering in our unit 4. So first of all, to know the definition of the wastewater, here a wastewater is coming from the domestic and all type of liquid waste is coming from the domestic and as well as industrial purposes and community, that is called as a wastewater. So wastewater, it contains the many impurities like suspended impurities are there, and colloidal impurities are there, and dissolved impurities are there. So these are the different types which are present in the liquid waste that is coming from the community. So going to in detail, so first one is wastewater. So wastewater, it is a term that is used to describe waste material that includes the industrial waste and domestic waste that is collected in towns and urban areas, and that is treated at urban wastewater treatment plants is known as a wastewater. So here the all type of liquid waste like sewage or garbage and sewage, so these are the wastes coming from the community or industrial, that is known as a wastewater. So it contains the many impurities. Coming to why wastewater is treatment, the main purpose of the wastewater treatment is to remove the contaminants from the water so that the treatment water can meet the acceptable quality standards. So here, so sewage water, it contains the many impurities. So such after time passes, that impurities are decomposed to give the color and odor and taste to the water. So that's why the most of the wastewater, it can be treated first. So after the treating process, that sewage water is converted into a fresh water. That water which is suitable to for the consumption of the, for it is suitable to use consumption purpose and a domestic purpose and industrial purpose, and also it is leads to reach the acceptable quality standards. So quality standards means in that water, so what is the color is represented and what is the taste is, and what is the taste is availability, and what is the temperature of the water, and the turbidity of the water, and chemical pH, what is the pH value of the water, and water, and what amount, what amount of chlorides which are present in the water, and nitrates and ammonia. So these are all impurities which are present in the wastewater. All these are within a permissible limits. So where the permissible limits are present in the water, so that water is properly or normally maintain a acceptable quality standards. So here, so sewage, the sewage characteristics are there. So the sewage characteristics can be classified into three types: physical characteristics and chemical characteristics and biological characteristics. In this physical characteristics, so there are the some factors are there, some characteristics are important. Mainly first one is temperature. So if the temperature of the water will be very high and more than the 20 degrees centigrade, so the biological activity will be more. So in that cases, so the decomposition of the organic matter and by the algae and fungus, so the biological activity will be more. So that's the result in the more contaminated. So the water is more contaminated, so which is not suitable for the consumption purposes. And the second one is color. So color, it is gives to the freshness of the sewage. So initially the fresh sewage like yellowish color and light brown color, and after a time passes and stale sewage, it becomes a brown color and black color and thick brown colors. And third one is order. So in this order, so fresh sewage is initially and oily order or soapy order. So after a time passes, the sewage will be converted into a it has a offensive order about of the sulfur dioxide and sulfurs. Coming to turbidity, so turbidity which gives to the what is the freshness of the water. So it contains turbidity. These are turbidity is measured by the turbidity rod and by the using of nephlorimeter and by using the Jackson turbidity meter and by using the Blaise turbidity meter. So this turbidity meter which presents the what type of impurities or which present in water, so that indicates the turbidity. And coming to chemical characteristics, total solids, so in these solids suspended solids are there and colloidal solids are there and dissolved solids are there. So suspended solids, the size of the suspended solids is varied about greater than the 1 micron, and colloidal solids the size is varying about the 1 microns to 10 to the power of minus 3 microns, and dissolved solids is varying from the less than 10 to the power of minus 3 microns, which are calculated by using of the filters and by using of the by using of the formulas. That formulas is total solids is equal to suspended solids plus dissolved solids. So here the formula, so we get known about the how much amount of the suspended solids which are present in the wastewater and how much of colloidal particles which are present in the wastewater and how much amount of dissolved solids which are present in the wastewater. And coming to pH, so pH initially the sewage water initially in the alkaline conditions. After the time passes, so it contains the many impurities. That impurities becomes a converted into a organic matter. The organic matter which affect on the water, so which is converted into a acidic nature, and acidic nature is greater than the 7.2 ppm. 7.2. So if the pH, and after a while the acidic nature is converted into a alkaline conditions. And third one is chlorides and nitrates and fats and greases and dissolved oxygens and COD and BOD. So these are all which are in present in the within the permissible limit. For example, DO. So we clearly observe the DO. So DO which present in the wastewater. So minimum is about 4 ppm, and BOD. So BOD means biochemical oxygen demand. So in this treatment, so the how much amount needed to decompose the organic matter which present in the wastewater, that oxygen is called as a biochemical oxygen demand. This test is suitable for the 5 days at the temperature of 20 degrees centigrade, and also finally, and which gives to the 70 percentage of the BOD results. So compared to it initially, it will take 2 to 3 months time. At that time, it is also represent the result 70%. So that's why we consider the test is operated at the 5 days at the temperature of 20 degree centigrade. Next one is biological characteristics. In this biological characteristics, bacteria and protozoa, fungus and worms which are present in the waste water. Coming to treatment process, this treatment process can be classified into three types. First one is physical treatment, and second one is chemical treatment, and third one is biological treatment. Next one is wastewater treatment process. This wastewater treatment process can be broadly categorized into four types. First one is preliminary treatment, and second one is primary treatment, and third one is secondary. Sometimes it is also called as a biological treatment, and fourth one is tertiary, and sometimes it is also called as a advanced treatment. So, coming to in detail. So first one is preliminary treatment. This preliminary treatment, the main objective of this treatment is to remove the solids from the wastewater. So solid means the type of any solids, suspended solids, dissolved solids, and colloidal solids which are present in the wastewater, that is removed from the wastewater. That process is called as a preliminary treatment. So in this preliminary treatment, some techniques applied for the some techniques applied for the treatment purposes. They are, so first one is screening, and second one is grit removal, and third one is skimming tanks. So first one is screening. So screening is the first unit operation used at a wastewater treatment plants. So in this screening removes the objects such as racks and papers and plastic covers and metals to prevent the damage and clogging of the downstream side equipment, piping and appurtenances. So in this screening process, modern wastewater treatment plants use the both screens and fine screens. So here in this treatment, so screens are using, so on the screens placed at an inclined at the 45 to 60 degrees across the flow of the water, so which is helps to more amount of solids clogging on the upstream side, and water safely moves to the downstream side, and also it will increase to the upstream side flow area, and as well as velocity will be increases. So in that conditions, screens are using at a 45 to 60 degree centigrade to the across flow of water. So screens can be classified into three types. First one is coarse screens, and second one is medium screens, and third one is fine screens. So coarse screens, this classification is depends upon the size of the opening or size of the pores. In that especially coarse screen, the sizes vary between the 70 to 200 mm size of openings. That screen is called as a coarse screens, and a medium screen is size is about the 20 to 50 mm. That screen is called as a medium screen, and fine screen, the size of the fine screen is about the less than 20 size. So which are used to, so all collected from the waste material. It's collected from the waste material and safely downstream side, water freely move to the downstream side. So coming to grit removal, grits are small and non-biodegradable particles which are heavier than the suspended organic matter. So in this grit removal, the heavy inorganic materials like sand and ashes and other can be removed by using grit chamber. So in this grid chamber, so there is a rectangular tanks are there and square tanks are there. So one side of the tank is connected to inlet and another side of the tank is connected to the outlet. So water passing through the inlet, the water is collected to the tank. So in the tank, after a time passes, that most of the suspended organic matter which settle down at the bottom of the tank within the detention time period. So that is that settleable solids are cleaned by the mechanical straining and levers by using levers. Coming to the skimming tank. So skimming tank is a chamber. So arrangement that the floating matter like oil, fat, greases, etc. rise and remain on the surface of the wastewater until removed. So when the liquid flows out continuously under the portions of the buffalo beds before the processing in skimming tank is known as a skimming tanks. We clearly observe that the image shows the skimming tanks. It is a closed tank. So it contains the it constructed with two buffalo walls, and the bottom of the tank it contains the air pushed air diffusers. So these air diffusers which are helps to to allow the air into the skimming tank. So with the help of the air, the most of the sewage water will be trickled by the air. So on that process, the most of the solids are settled down at the bottom of the tank. Bottom of the tank without any external pressures. So with the help of the skimming tank, after the skimming tank, so that water is going to be next treatment unit. So coming to next stage, that is primary treatment of the sewage. In that primary treatment, which is used to remove the fine suspended organic solids that cannot be removed in the preliminary treatment. So in this treatment, some techniques are applied for the primary treatment of the sewage or sedimentation and mechanical fluctuations and chemical fluctuations. Coming to first one, that is sedimentation. In the sedimentation, the solid particles of the sewage tends to settle down due to the gravitational force, and it means without any force the suspended solids are settled down at the bottom of the sedimentation tank. Second one is sedimentation is done in the sedimentation tank. In the sedimentation tank, so the settlement of the solids and based on the size and shape and density and viscosity and velocity of the sewage. So size of the particle, if the size will be more, the settlement will be very high. If the size of the particle, the shape of the particle is irregular shape, that particle settle down, it will take time to settle down at the bottom of the tank. And also, so density of the particle, so density of the particle will be more, so the settle down bottom of the tank will be very low, so compared to the flow of the sewage. So if the viscosity of the sewage and velocity of the sewage will be very high, at that conditions the suspended matter settled down at the bottom will be very low. So all these factors which are effect on the sedimentation tank to settle the suspended matter. So he clearly observed that the image shows sedimentation tank. The sedimentation tank with attached with left side is inlet and right side is outlet. So here the sewage water coming through an inlet pipe. So inlet pipe, through an inlet pipe the sewage is collected in a sedimentation tank. So after the time passes, due to the gravitational force, most of the suspended organic matter which settle down at the bottom of the tank, that settle down but solids that will be converted into a sludge, because of that water is going to be upward towards to the surface of the sedimentation tank, and floating matter which present in the wastewater that accumulated on the surface of the water, that will be converted into a scum. So that is freely cleaning from the by using mechanical straining and labors. So after the sedimentation tank, most of the particles settle down at the bottom of the tank. So the remaining water go through outlet pipe into the next treatment unit. Okay, clear? And next one is mechanical flocculation. So in this flocculation, water and wastewater treatment, so flocculation is used to remove the suspended solids from the water. So this is done by adding of the flocculant to the water, which causes the suspended solids to clump together and forms to flux. The flux are then easily removed from the water by using sedimentation and filtration process. Here the image shows mechanical fluctuations here. So the raw water which is coming through an inlet pipe. So the inlet pipe, the closed inlet pipe, the closed tank, so which connected with the inlet pipe and outlet pipe. So here and also connected with the pump flash mix, that is a pedal is there, and the bottom of the pedal, the bottom of the rod, the paddle is connected to the rod. So while coming to the raw water through an inlet pipe, so that water which contains the organic matter, so that can matter removed by the mechanical fluctuations means. So if the water enters into the tank, after the tank, the straining for the flash mix clockwise in a 20 rpm at the temper at the 20 rpm, and rates per minute, revolutions per minute to at that 20 revolutions per minute at that time. So in this organic matter and the floating matter which is connected to together, it gains to the weight and it gains to the size, and at that time, at that conditions, the size will be increases. At that time, the particle can be settled down at the bottom of the mechanical tank. So mechanical tank, after that, that water is going to be next treatment unit, that is chemical fluctuations. Chemical fluctuations, that is done by the adding of the flocculant to the water, and which causes the suspended solids to clump together and form flux. This flux are easily removed from the water by using sedimentation and filtration process. Here clearly observe that, so chemical fluctuations. So first one is one beaker is there, and second one is beaker is there, and third one is beaker is there. So three beakers are interconnected to each other. So first beaker, the raw water through an inlet pipe. So in that beaker, so coagulant is added. So aluminum sulfate. So one of it is also called as a alum. So while adding of the alum, so after the time passes, the suspended particles after the time passes, suspended particles attract the alum. So in that alum attached to the particles, that will be converted into a flux. So the flux, one of the advantages to attract the floating matter and finer particles which are present in the wastewater, thus result in the that suspended matter which gains the weight and also shape and also size. So in that conditions, most of the particles settle down at the bottom of the tank. So we clearly observe that third beaker, so only suspended solids are there. After the suspended solids, the what is going to be next treatment units. Thank you.